The RUCPAD is a wearable technology created by the National Security Innovation Network, or NSIN, and the Tatitlek Corporation. NSIN is an office in the United States Department of Defense and uses resources from the Department of Defense to encourage innovation within defense. Tatitlek provides services to defense contractors and other federal and private entities. The RUCPAD is designed to be a wearable charge pad for drones, carried on the back of warfighters into remote situations where drones will be utilized. Once set up, the RUCPAD can be left behind for future use in the field. The RUCPAD can also be used on vehicles where it is strapped down and the drones can charge and deploy autonomously while the vehicle moves. The original RUCPAD design we were supplied by NSIN and Tatitlek weighs 55 pounds, is over 28 inches long and 23 inches wide, and is very uncomfortable to wear as a result. With this background, we set some objectives for improving this design.
Our team was tasked with creating a manufacturable RUCPAD. Our objectives were a 45% reduction in weight from the original 55 pounds to 30 pounds and reducing the footprint to a maximum of 1.5 feet by 2 feet. Also based on our original findings, we expected to provide a 30% improvement in ergonomic properties. Our constraints for this project were mobility. The system must be transportable as a backpack or can function as a backpack, ensuring ease of movement across various terrains. Vehicle use. The design must allow for stable operation on top of a vehicle, considering factors like vibration, potential weather, and other environmental conditions. The universal usability. The backpack and the charging system should be user-friendly and accessible to all warfighters, including those of varying sizes and physical capabilities. The size of the charging plate. The smallest dimensions for the charging plate were 8 inches by 8 inches. Ease of deployment. The backpack must be capable of housing the charging plate and associated materials with the potential for use on top of a vehicle and rugged terrain. The size of the components. We could not modify the size of any of the electronic components contained within this system.
The original RUCPAD weight is the most significant concern, as it negatively impacts both the usability and the ergonomic safety. At a total weight of 55 pounds, the RUCPAD far exceeds the military guideline for limiting loads to 1/3 of the user's body weight, making it unsuitable for prolonged use in active duty scenarios. This excessive weight causes strain on the spine, legs, and joints, increasing the likelihood of musculoskeletal injuries. During testing, simulated use of the 55-pound RUCPAD revealed high to very high risk in ergonomic scores across all tested scenarios, including walking 27 feet and navigating stairs. Beyond its excessive weight, the current RUCPAD design lacks several necessary components required for full functionality in the field. Essential items such as assembly-ready mounts and secure housing for electronic components are absent, limiting its usability and increasing the logistical burden on users who must carry additional equipment separately. These gaps, combined with improper weight distribution of the pack, further exacerbate ergonomic challenges by causing imbalanced loads and increased spinal strain.
The current weight, even without all the required components, highlights the urgent need for redesign.
Addressing both weight reduction and integration of essential components, it is critical to creating a more ergonomic, efficient, and practical solution for military operations in remote and high-intensity environments.
Team 3 utilized the Rapid Entire Body Analysis, or REBA, as an evaluation process for determining the risk of injury. This process allowed us to account for the amount of force that the body was experiencing during the task and to score each major body segment separately. After scoring, the scores were all combined to generate an overall risk level, ranging from low to very high. High scores indicated a need for immediate ergonomic changes. Using REBA in our approach enabled our team to identify each design's risk to potential users quickly.
Our design consists of a box that contains all the electronic components and integrates the charge pad into the top as well, protecting the components from weather, dust, and debris. To allow for storage of the batteries and drone within the system, a second collapsible box with a canvas bottom was added on the outside of the main box. This allows for the box to maintain minimal footprint when not being used to store anything, while also including the capability of traveling with additional supplies in itself. We also included leveling feet and antenna clips that prevent the drone from slipping off of the system while charging, and for safe transportation of the antennas respectively.
Over the course of the last 4 months, we have been able to create a new RUCPAD that's 59% lighter, between 50% and 72% smaller, depending on if it's open or closed, and has 30% lower risk ergonomically. These benefits have turned the RUCPAD from a solution that could cause harm or inconvenience the warfighters to a design that can be carried more safely and for further missions. NSIN and Tatitlek will be moving forward with this design and creating a new prototype for use with troops. Based on their further testing, the ruck pad will be implemented in the field once the design has been proven effective.